Welcome to Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. This episode comes to you after the April 8th, 2024 total eclipse of the sun, which swept across North America, bringing one last solar show to the first quarter of this century. I was lucky enough to get to see totality, and some of you got to see me do it on the Weather Channel, where I might have been muted after an overly excited utterance of holy excrement. Note, I did not say excrement. I might not have been muted had I said that. Anyways, I hope many of you got to share this amazing experience. Usually an eclipse touches any one place on Earth just once every 300 to 400 years, and it was a complete statistical fluke that allowed folks like me to have a once-in-a-lifetime experience twice, both in 2017 and 2024 in the city of Carbondale, Illinois. In the coming weeks, we're looking forward to bringing you the results of the numerous science experiments that took place during the eclipse. It will take folks weeks to months to publish their data and let us know their results. This week, we do, however, have some solar science that isn't eclipse related. But it sure does affect the Earth as it talks about our future fate. For those of you who don't worry about the things so far in the future as when the sun dies, we also have news on a massive solar storm from 1859 and consider what would happen if the sun acted out the same way today. All this and more is coming to you right here, right now on EVSN, a product of CosmoQuest. Recent research published in Science Advances and led by Madalena Vasseniu finds that when it comes to climate change, we can't scare people straight. Stories of gloom and doom focused on the fate of our world don't inspire people to change their ways and listen to the scientists. Instead, their 59,000-person survey found that it is through emotion that people can most be impacted. They found that asking someone to write a letter to a child's future self about what we're doing in 2024 to prepare the world to be a good place in 2055 actually causes 5 to 10% of the people writing to support new actions that will slow climate change. That is actually a really impressive number of people in this world where it seems like everyone is dug in on their current viewpoints and unwilling to change. So, when I hear my friends are setting up email accounts for their newborns and sending that kiddo letters about their life, I'm now going to ask them to write to that child about what they did to change the world. It's a small thing. But if enough people care about how large companies and governments behave, maybe us little people can influence global change. A group of climate scientists have taken the idea that storytelling is more effective than fact-telling in directions I would never have anticipated, and that I am totally here for. Researchers led by Patrick Keyes have explored what stories naturally arise from changing where and how water flows through our atmosphere. As they put it, quote, humanity is modifying the atmospheric water cycle via land use, climate change, air pollution, and weather modification, end quote. Over the course of numerous workshops, researchers looked at a variety of science-driven storylines that arise from these changes and identified what kinds of effects these storylines have on people and the economy. Ultimately, they created a variety of well-defined scenarios ready to be told, and then they wrote some of these stories. and put them somewhere I still haven't found. But I'm going to keep looking, and I'm going to write the authors, and when I find those stories, I'll link to them at evsn.tv. For now, we're going to post their scenario descriptions, which read like notes to a game master on how to construct a world. For instance, the scenario, "We are as gods," is set in a world where scientific advancements in the manipulation of seasonal precipitation for agricultural production are the norm. And the story is set after a speech by a fictional Dr. K. Rasmunforti, recipient of an inaugural AGU Tessendorf lectureship on weather modification, in which they speak about the history of weather modification and the dangers it may pose. As so often happens when researchers write stories to communicate science, the plots aren't the most dynamic, but they are a whole lot more interesting than reading the research papers. This is a start, and I look forward to seeing what happens when researchers partner with authors to do even better storytelling, in what I hope is the near future. For now, I leave you with this story prompt. In a world where weather is privatized to the extent that rainfall and cloud cover can be requested if a customer can just pay the price, a farming household in Germany must see if they can outbid a neighbor to secure the precipitation that they need for their harvest. This could be our future. And through storytelling, now we can define just how that future might look and hopefully make that future not happen. Get to writing, people. Let's give humanity a happier third act. As scientists discover and explore atmospheres of more and more planets orbiting stars other than our sun, we are learning that if you can imagine it, it probably exists. In a new paper discussing the planet WASP 76b, researchers led by Olivier Damagian describe what appears to be a giant rainbow in the atmosphere of another world. And folks, this isn't some mundane double rainbow. This is a glory, a circular rainbow. And it's not water that is refracting starlight. It looks like this rainbow may come from atmospheric iron. Seen on the planet's eastern terminator, that line between day and night that corresponds to sunset, this remarkable spot is thought to be the first rainbow spotted outside our solar system. This particular kind of rainbow can be seen on Earth by folks positioned above stable cloud layers. I've seen them from an airplane where a glory formed around the plane's shadow. Climbers often see them around their own shadow on clouds below them. I didn't know that they could form on a planet's own shadow, and I love learning these kinds of colorful facts. Now, to see if we can get Lisa Frank to make art with this information. Atmospheres are what make a planet good or evil for life. One of the questions I get asked most often is, can we terraform Venus to be like Earth? Sure. Just don't expect it to stay that way. Our Earth has a strong magnetic field that bends away a lot of the sun's nastier attempts to strip away our atmosphere. This magnetic field is generated deep inside the Earth and exists because we are big enough to still have an ooey-gooey dynamo-making structure, unlike Mars, which has cooled to be a lot more solid and mostly magnetic-free. It also exists because we are rotating fast enough for charged particles in that ooey-gooey goodness to work a bit like an electromagnet, unlike Venus, where slow rotation leaves the ions without the same opportunities. We really are the baby bear of planets, with everything organized just right for life. And researchers now think the same may once have been true on Venus as well. Our overheated twin likely once had oceans and water just like us. And using the Bepi-Colombo spacecraft, researchers are working out the details on how Venus became the acid bake oven of our solar system. This mission, destined for Mercury, passed through Venus's space on August 10, 2021. It flew in from behind and experienced an induced magnetic field generated by the sun pushing ionized particles into motion. Using its onboard mass spectrometer, Bepi Colombo was able to identify hydrogen, oxygen, and carbon molecules, ions, and the mission was able to literally detect the stuff needed to make water and to make life getting blown away in the solar wind. This first of its kind measurement can't be made by an orbiter. They just don't explore the needed parts of the environment around a planet. It took a flyby from a mission with a totally different destination to make this discovery. This is your friendly reminder. When NASA, ESA, and other nations plan out missions to other worlds, a lot of effort goes into finding additional science those spacecraft can do en route. Just like your road trip might add in a stop at the world's largest catch-up bottle, mission planners add in all the tourist sites, or at least all the worlds and space rocks that are along the way. Up next, we look at our own planet Earth and explore the interplay of the sun, ice, and our future. Stay tuned. I'm recording this episode on April 17th, 2024. Last night, while contemplating the insanity of wanting to turn on the AC so early in the year, a June bug in April flew through the open back door and it engaged me in a battle as it fought to find residence in my hair. It was evicted. This kind of human versus insect battle is a yearly occurrence, but normally it is staged in June, because that is when June bugs are supposed to emerge from their underground burrows. This early invasion of scarab beetles is my personal reminder that as our world is altered by climate change, flora and fauna of all kinds are going to change the when and where of their appearances. We are starting to see armadillos in Illinois as the armored critters walk north in search of better weather. We're also seeing creatures from other parts of the world, like Japanese stink bugs, thrive as they find a climate they like in an entirely new part of the planet. Global travel and trade are making it easier and easier for invasive species to make their way to new parts of the planet, including places where little to no life was once visible. In a new paper in Neobiota, with first author Peter Tischik, researchers document how life forms introduced by whalers and sealers in the 19th and 20th century are now thriving on once glacier-covered landscapes. As the Nordenskjold Glacier retreats on the remote Antarctic island of South Georgia, newly uncovered stretches of ground are starting to grow. Since this is an ongoing process, there are regions that were laid bare longer ago, regions that were just revealed, and everything in between. By looking at the density of life across all these different regions, researchers were able to piece together how invasive plants and animals fill these newly created landscapes. As they describe in their press release, quote, "Just a few years after bare ground is exposed by glacier melting, pioneer plants arrive, progressively covering more ground with time and followed by an increasing number of species." End quote. Included in the mix were plants native to the northern hemisphere, including meadowgrass and mouse-ear chickweed. These plants are literally filling in the landscape where no plant had gone before. It is impossible to know what the world will look like when the glaciers are gone, but this study makes it clear. Life will find a way to fill every niche in the new ecosystems. As glaciers around the world transform into rivers and ultimately dry ravines, entire ecosystems will be changed forever. While we often talk about the problems that will be faced by polar bears and penguins, we must also consider the less fluffy endangered creatures, such as the rare planetary science graduate student. This starved for data subgroup of humans, along with the more common geology graduate student, is known to migrate by the dozen to glaciers every summer as they search out one of their favorite research foods, meteorites. Working side by side with members of their subgroup who have somehow survived to become senior scientists and faculty, these early career researchers learned to forage along the melting ends of glaciers and along their surfaces for meteorites that have landed on the glacier at some point in history and have now been revealed by the glacier's melting. It is estimated that 300,000 meteorites are at the surface of the Antarctic ice sheet. During their summer meteorite hunt, eager researchers can gather up to 1,000 meteorites that can feed them for months or sometimes even years. Without climate change, these rare scientists could go centuries without needing to find new hunting sites. Unfortunately, because of climate change, things are going to get much harder for these young researchers. With every 1/10 degree of warming, it's estimated 5,100 to 12,200 meteorites will be lost from the ice sheet. By 1050, it's estimated that a quarter of these precious space rocks could be lost forever. These lost space rocks could contain the samples needed for these students to get PhDs, or maybe even to help them discover life from other worlds. It is up to all of us to protect all the rare and endangered flora, fauna, and researchers on this world. In the words of Harry Zakorli, quote, "To secure this invaluable extraterrestrial material, we need to intensify and coordinate the recovery of Antarctic meteorites before we lose them to climate change. In similar efforts as collecting ice cores from vanishing glaciers or sampling coral reefs before they bleach, our study identifies the loss of meteorites as an unexpected impact of climate change upon which we need to act." End quote. If you want to help protect these students, please consider donating to your local geology and planetary science programs, getting involved in efforts to restrict greenhouse emissions, and spreading the word that space rocks and the grad students who research them may just be the next victim of climate change. Our planet is constantly changing under the forces of humans, geology, and even the sun. And while we can see what humans do daily and what geology does through quakes and eruptions almost weekly, catching the sun being its bad self is a lot harder because it's a lot more rare. The biggest of big solar outbursts in modern history occurred on the first days of September in 1859. A massive complex of sunspots released a powerful geomagnetic storm that was documented by Richard Carrington and Richard Hodgson. Not only was this the first solar flare ever documented, it was also the most powerful ever documented to hit our Earth. As ionized particles from the sun lashed the Earth's magnetic field, they generated electrical fields in the early electrical power grid and caused blackouts, while also allowing the telegraph network to work with the batteries disattached. While lots of accounts of this event exist, few of them allow us to measure the size of this event in a way that allows direct comparison with other solar flares. Now, in a paper published in Geophysical Research Letters, researchers present direct measurements of a spike in radiocarbon concentration in tree rings formed after the event. While high-energy particles from the sun interact with our upper atmosphere, it can produce carbon-14. Over time, this unstable carbon atom can sink into the lower atmosphere, get combined into carbon dioxide molecules, and get drawn into plants. Researchers looking at trees in Lapland separated out carbon samples formed across time and were able to identify the increased carbon-14 from the Carrington event. In the life of some trees, the 165 years since the Carrington event is just a blink of the eye. This technique will now make it possible to determine, using tree ring samples going further back in time, how common this size of an event may be. Large storms are known to have taken place in 1730 and 1770, but in the pre-electronics era, there just weren't means to study the storms beyond noting where auroras were visible. Tree rings just might give us added details on intensity. When future results on these early storms are published, we'll bring them to you right here on EVSN. Living with a star today means we have a nice planet at a nice enough temperature to thrive, and we occasionally get treated to an amazing show in the form of aurorae. This is only temporary, however. 5 billion years from now, our happy golden sun will transform into a red giant star that has had generations wondering, will the sun one day eat Earth? According to a new paper in the monthly notices of the Royal Astronomical Society, with first author Amarant Engwerajewit, it appears that our sun will indeed engulf our planet. And that could be the easy way out for our world. Yeah, that's the good ending. Their 17-year study of white dwarfs finds that these former sun-like stars are often surrounded by planetary debris disks, where planetesimals undergo disintegration. The stars also show metal pollution in their light, implying they are nibbling, or more scientifically put, accreting, what remains of the star's former solar system. Having read my fair share of fiction, I feel comfortable saying I'd rather our planet get engulfed all at once rather than nibbled away at through collisions and accretion. Opinions may vary. Let us know your thoughts in the comments. Up next, I fill in for Erik Madaus and bring you all that's new from the launch pad. Stay tuned. We have 2 weeks of rocket news to cram into this one too short segment. Let's get on with it. On March 30th, SpaceX launched the Intelsat 36D satellite on a Falcon 9 rocket from Slick 39A in Florida. Eutelsat names their satellites by what orbital position they will fill. 36D will provide TV broadcasting to Africa, Europe, and Russia from 36 degrees east. It weighs over 5 metric tons and uses electric propulsion. On March 31st, Russia launched the 4th Resurs-P weather satellite from the Baikonur Cosmodrome in Kazakhstan. Resurs-P is a commercial Earth observation satellite based on the Yantar 4K-S1 military reconnaissance satellite. It has a 10-meter ground resolution. So yeah, it can watch football games. It just can't see the players. On April 7th, SpaceX launched the Bandwagon 1 rideshare mission on a Falcon 9 from LC-39A. Bandwagon 1 is a dedicated rideshare to place numerous satellites in a 45-degree orbit, including Arcadia 4 by Capella Space and 425 Project Flight 2 for the South Korean government. Unlike SpaceX's transporter rideshares, this one targeted a 45-degree orbit. Arcadia 4 is the latest in a series of orbital SAR satellites. Capella will have an Arcadia 5 on a transporter mission later this year, headed to a more conventional sun-synchronous orbit. On April 9th, ULA launched the 16th and final Delta IV Heavy from Slick 37B at Cape Canaveral Spaceport Station in Florida. As is typical with NRO launches, no details about the payload were disclosed, and the webcast concluded after payload fairing jettison, which is for the best, honestly. No one wants to watch an animation of a rocket for 20 minutes. Anyways, some hours later, ULA declared mission success. While it shares nothing but a name with the original vehicle, this launch capped off 60 years of Delta rocket launches. Of those 16 Delta Heavies, all of them were for the government and all but 3 for the National Reconnaissance Office. The very first flight carried a dummy payload. The other 2 non-NRO flights were NASA's EFT-1, an uncrewed test flight of the Orion spacecraft, and the Parker Solar Probe, also for NASA. The Delta II, the rocket that could actually trace its lineage to that original Delta, had its final flight in 2018. On April 11th, Russia launched the Angara A5 from the Vasheny Cosmodrome in the Russian Far East. This was the first launch of a rocket from the Vasheny Cosmodrome. Because of delays in other programs, no useful payload was ready for the mission, so instead it carried an Orion upper stage, which is the latest version of the Block D Russia and previously the Soviet Union had been using since the 1970s. It's modified for the Angara and incorporates fixes from the previous Angara 5 launch, where the upper stage failed. Also on April 11th, SpaceX launched the USSF-62 mission on a Falcon 9 from Slick 4E in California. USSF-62 is the Weather System Follow-On 1 spacecraft, the latest polar orbit weather satellite for the U.S. military. It has a microwave radiometer, useful for monitoring sea winds, cyclone intensity, snow depth, soil moisture, and other measurements. It also has a charged particle sensor for monitoring low Earth orbit space weather. There were also 7 launches of Starlink satellites from all 3 of SpaceX's Falcon pads. We track launches with the help of RocketLaunch.live. So far this year, the United States has had 34 launches, China has had 14, New Zealand has had 4 launches, Japan and Russia each have had 3 launches, India, Iran, and Kazakhstan each have had 2 launches. This makes the total number of launches so far this year 64, with 1 failure and 2 partial failures. Finally, there are 10 toilets in space. Welcome to orbit, Soyuz MS-25. Before we go, I want to draw your attention to one more thing. This week saw the passing of scientist Peter Higgs. At age 35, this British physicist published research that defined just how and why you and I and everything else is able to have mass. The field, the boson particle, and the mechanism through which they interact would all one day carry his name, Higgs, unless he was the one talking about them. Peter Higgs was only one of the scientists who advanced the symmetry-breaking equations necessary to explain how a new kind of boson could couple particles to scalar fields that permeate all of space, and how that coupling would create the measurable feature of mass. Described widely as a shy and humble man, Higgs would refer to the mechanism he worked on as the ABEGHHK prime TH mechanism for the Anderson-Brout, Englert, Guralnick, Hagen, Higgs, Kibble, and de Hooft. Thus, he gave credit to all who played a role in explaining mass. In a world where many researchers refuse to publish papers with more than 3 authors because they don't want to risk not getting a Nobel Prize for their work, this alphabet soup of names brings me joy. If you want to learn more about the search for the Higgs boson, I highly recommend David Kaplan's documentary film, Particle Fever. Peter Higgs received the Nobel Prize along with Francois Englert in 2013 for their separate work on defining that mass-making boson field and mechanism. Higgs passed away at age 94 on April 8th. And that's it for now. Good night, everyone. And remember, go out and look up.